Welcome to this explainer. Let's jump right into something truly fascinating today, the agricultural potential of biochar. We're going to unpack how agriculture can solve a massive, incredibly complex dilemma, which is how to produce more food while actively lowering greenhouse gas emissions. And we're going to do it by turning everyday waste into a profound climate asset. If you've been following the intersection of agriculture and climate tech, you're absolutely going to love this.
Think about this seemingly impossible equation we are facing right now. As our global population explodes, we absolutely have to produce more food. But at the exact same time, we need to use way less water, protect our rapidly degrading soils, and significantly lower our emissions. Sounds pretty much unachievable, right? Well, the answer might actually be hiding in plain sight, locked inside the massive mountains of organic waste that farms are already generating every single day.
Here's our roadmap for today. We're going to cover 1. The big dilemma. 2. The pyrolysis solution. 3. Agricultural superpowers. 4. The critical caveat. And finally, 5. A new paradigm.
All right, let's start with Section 1, the big dilemma, and specifically the agricultural waste problem.
You see, farms, forestry operations, even food production facilities, they generate massive quantities of organic residues. We're talking crop residues left in the field, pruning waste, wood chips, manure, you name it. And the old mindset, it treats all of this entirely as waste. Depending on where you are, this stuff is usually openly burned, left to rot, or expensively hauled away to a disposal site. It's kind of crazy because an organization ends up having a waste problem, a carbon problem, a soil problem, and a resource efficiency problem all at the exact same time. We really have to reframe this with a circular mindset. Instead of asking, how in the world do we dispose of this biomass, we need to be asking, how much environmental and economic value can we actually recover from it?
And that leads us perfectly into Section 2, the pyrolysis solution, or how we go about creating biochar. So normally, when organic waste decomposes naturally or just goes up in smoke, all of its stored carbon goes straight back into the atmosphere. Pyrolysis essentially short-circuits that entire natural process. Think of it more like baking rather than burning. By heating this biomass up under tightly controlled conditions with little to no oxygen, it doesn't actually combust. Instead, we convert that carbon into a super stable solid form called biochar. It's brilliant because it highly resists biological decomposition, meaning we literally capture and stabilize that carbon for the long haul.
It really is a beautifully straightforward chain. You start with raw biomass waste, you run it through this controlled pyrolysis process, you get biochar, and then you apply it straight to the soil. So instead of dealing with a rotting pile of liabilities, you've just engineered long-term carbon storage and built up serious soil resilience.
Which brings us to Section 3, agricultural superpowers, where we look at how this supercharges both our soil and the climate.
When you match the right biochar with the right soil, the cascading benefits on the ground are kind of mind-blowing. For starters, it's officially IPCC recognized for serious, long-term carbon removal. But physically, down in the dirt, it acts like a microscopic sponge. In areas getting hit hard by drought, it fiercely holds on to water, boosting resilience and cutting down on how much we need to irrigate. Plus, it keeps expensive fertilizers locked right there in the root zone, which drastically reduces the pollution risks from agricultural runoff. And because of its unique surface chemistry, it can even immobilize hazardous soil contaminants like certain heavy metals. It is absolutely an agricultural super tool.
But to really unlock these superpowers, we have to rethink how we look at the ground beneath our feet. Soil shouldn't just be treated as a dumb production surface, you know? It needs to be managed as a living, natural asset. Now, biochar isn't a magic wand that just replaces good farming practices. The real magic happens when you combine it with regenerative agriculture, things like compost application, cover cropping, and reducing soil disturbance. That is how you truly bring degraded soils back to life.
Now we have to talk about Section 4, the critical caveat, which is a much-needed green reality check.
Here's the catch, and this is super important. Just producing biochar doesn't automatically guarantee you're helping the climate. Not at all. If you have an unverified process, you might be blindly applying it to the soil, which can totally wreck crop performance. Or you might be using contaminated feedstocks that just dump heavy metals right back into the earth. Even worse, if your pyrolysis process is poorly controlled, you could actually increase air emissions. To genuinely help the planet, you absolutely need a credible system in place. That means strict emissions controls, defined application rates, and incredibly rigorous carbon accounting.
Because of those very real risks, we have to stop asking the wrong question. The wrong question is just, hey, did we produce biochar? The right question, actually,
The only question that matters for true sustainability is, can we demonstrate, with hard evidence, a net environmental and climate benefit? That simple distinction is what separates a truly credible environmental solution from a total greenwashing claim. You have to prove that the entire system, from where the biomass came from all the way to its final impact on the soil, is a net positive.
So how do you actually prove that? Well, you need a bulletproof MRV framework. That stands for measurement, reporting, and verification. You have to trace the whole evidence chain. You document exactly where the biomass came from. You track the energy used during pyrolysis. You rigorously test the carbon stability and check for contaminants. And then you prove it all with independent verification. Without that complete evidence chain, well, you've got an interesting material, sure, but you definitely do not have a credible climate solution.
All right, let's bring it all home with Section 5, a new paradigm, looking at what the farm of the future really looks like.
If we nail this life cycle tracking and get that MRV framework right, we unlock a totally new, incredibly holistic vision for farming. Biochar isn't just some basic soil amendment. When governed properly, it ties multiple massive global goals into one unified system. We're talking waste management, a circular economy, soil health, climate adaptation, and verified carbon removal, all happening at the exact same time. The farm of the future won't just be a place that pumps out crops or livestock. It's going to operate as an advanced resource management hub, converting everyday biological wastes into recoverable energy, super productive soil inputs, and durable carbon storage all in one go.
The craziest part? The technology to achieve this incredible circular economy already exists today. It is literally right here. The real challenge is simply building the quality controls and that solid evidence chain to prove it works. So I want to leave you with this final vital question to think about. How much biomass does your organization or even your community currently classify as waste that could actually become a measurable environmental asset? This incredible untapped potential is literally lying right beneath our feet, just waiting to be transformed. Thanks for joining me on this explainer, and I really hope this sparks some new ideas for how we can rethink waste and heal our soils.